All right, guys, good afternoon, everyone, and welcome to today's class. So it's exactly 16:10. I think we can commence our class. So today we'll continue looking at integration. We started looking at integration. And today we continue looking at more problems involving integration. So we've the questions, the integration that we did yesterday is all the functions that we did were somehow in standard form, but sometimes it happens that an integral is not in standard form, so we need to use something. So we're going to look at integration using algebraic substitutions, which can help us to go straight forward and find the integral of a function given. So we have that. We can, given a function, say by using algebraic substitutions. So we can use an algebraic substitution. We have said sometimes we can also use a trigonometric or hyperbolic substitution. It will still be the same. And then sometimes we can use partial fractions. Sometimes we can use a substitution for say t being equal to tan theta by 2. We substitute a function by that. Then sometimes we also use the integration by parts in the sometimes the reduction formula. I'm sure which I don't think it's there in first year. So you look at. So that's what you're going to look at. So for today, with an algebraic substitution, so we seek, say, of the form, we seek an integral of the form of, say, k. Then you are integrating this one. Then you have f of x. So this f of x is to the power n. Then times, say, f prime of x dx. And functions of the form, say, you have a constant k. Then this one is, you have something like this in the numerator, and then you have, say, f of x to the power n dx. For this one here, you can substitute this one. You can let say any letter, but we are used to u. So you can let u equal to f of x in this case. F of x, not f prime of x, f of x. You can let that equal to f of x. And then you can substitute your dx by something where dx will give you something like du. So you need to find a du. So you go find, say, your du in this case. Dx is equal to, say, f prime of x. And then you're going to see your du over f prime of x is what will give you your dx. So you substitute the dx with this one. There you see everything will become easy, and then you do the integration. Okay, let's understand this with an example. So you can look at example 1. So example 1, determine say the integral of cos 3x plus 7 dx. Okay. So that's what we have. So some concepts we are going to be learning them as we are doing the questions. You know, we have can establish this one. We have the integral of, say, cos say 2a, say dA, that this one is simply equal to, so you see, when you have this one, you can let say your u equal to your 2a, so that your du dA is equal to 2, and then this one, then du over 2 is equal to dA. Then you are going to have this one here as cos u. Then you're going to have, say, this one here. The dA is this one, which is going to be the du over 2. But this one is equal to 1 over 2, the integral of cos u du. So that becomes easy, and you can do the integration from there. So let's look at this specific example. So from here, you see, we need to find a more standard form of cos, the function cos. This one, the standard form, we mean, say, cos x. That is a standard form, and that is easy to integrate. So for this one, we can let our u equal to this one, the 3x plus 7, and then you find your du dx to be 3. Then here, we can cross multiply to get du is equal to 3 dx. To find dx, you divide both sides by 3. So you have your dx will be du over 3. So in this case, so this integral cos 3x plus 7 dx is going to be equal to the integral of cos, there's a change in the variable cos u, then dx is du over 3. This one is going to give you, this one you can pull out the 1 over 3 there, cos u du. And we know the what you get when you integrate this, because we have, when you differentiate sine x, you get cos x, and then d dx of sine x, I mean cos x, is equal to minus sine x. So when you integrate both sides, it's like you're just reversing things here. So here, when you differentiate both sides, the integral of this one is simply b sine x. So this one is going to be 1 over 3 sine u plus some constant c. Then we're going to get this one as, you know, your u is well known, which will be 1 over 3 sine u, which is 3x plus 7, and plus c. And that's what you get there is your final answer. Yes, I can get you that. Now you can't get you are breaking.
Okay. I was trying to find out that sign isn't have a negative sign. After the second part from the bottom, that is supposed to have.
Where? I still can't get you. I still can't get you. Okay, send a message. Send your message. I'm going to read. I'll be able to read. So let's move on. We have another problem example. So that was example one. Let's look at example two. Let's look at example two. So example two, we're being asked to find the integral of 2x minus 5 to the power 7 dx. Right. So let's look at this one. So, guys, with this one, you can do what we were doing yesterday, which will require you to expand this. I know we are good at binomial theorems and the binomial expansion, so you can use the binomial expansion and expand this and then integrate, but that will consume some time. So we can just use an appropriate substitution here, where you say, in this case, you can let u equal to 2x minus 5. Then you find your du dx being equal to 2. Then this will mean dx is equal to du over 2. So having that, then this our expression here, the integral of 2x minus 5 to the power 7 dx will be equal to the integral of u to the power 7 times du over 2. And then that becomes easy. You can integrate from there. So this one you get 1 over 7. Okay, but let's simplify this one. This one is equal to 1 over 2. The integral of u to the power 7 du. And then you're going to get 1 over 7 plus 1. You have a 1 over 2 outside here. Then you have, but you should, this 1 over 2 is only being multiplied to this one. You should see that. Then you have the u to the power 7 plus 1. Then plus your constant c. So this one you're going to have 1 over 2, 1 over 8, u to the power 8, and plus c. Then you're going to get, this one is u to the power 8 over 16 plus c. But you know what your u is. So the u is simply 2x minus 5. So this will be 2x minus 5 to the 8, all that divided by 16, then plus your constant c. That's what you get there. Our third problem. So here we were just doing a substitution by, I want to take you guys step by step. So here we're just doing substitution by an algebraic expression. So this is what we're doing. So for 3, we're told, say, find 2 sine, there is 4x plus 9 dx. Right. So guys, here the argument is here you cannot go direct like you have sine, say, x, and then you go direct to say, okay, this one is equal to minus cos x. But here you have, and say sine 4x plus 9 is equal to minus sine 4x plus 9 or minus cos. No. So that is not correct. So here we need to do some substitution here because this is not in standard form. So as usual, you let your u equal to this one, what is inside, which is 4x plus 9. Then your du dx is equal to 4. Can we please mute our mics? And then you have dx being equal to du over 4. That's what we have. Okay. So you see, guys, you can pull out the 2 there. It doesn't really matter. But this one here, so this one, 2 sine 4x plus 9 dx will give you the integral of 2 sine u, then du over 4. But this one is 1, there you get it, 2, and then the 1 over 2 can come out to give you 1 over 2 sine u du. This one is equal to 1 over 2 sine u integrated will give you a minus cos u, then plus c. Then we have this one, which will give you, let me write it here. This one is going to give you minus 1 over 2 cos u plus c. But you know your u is 4x plus 9. So this one is equal to minus 1 over 2 cos 4x plus 9. Then plus c. You are done. Okay. We proceed. All right. So we can look at our fourth example. So what I'm going to do, we are going to do, I'm just going to be solving. Then after this, I'm going to forward you a task that you need to do, and you need, for practice, you practice them at your own free time. So we need to show there's this question. This one is saying, show that the integral of tan theta d theta is equal to the ln of sec theta plus c. So you need to show that. So here, you need to show that this is equal to that. But you know, this one, the integral of tan theta is simply equal to the integral of, say, sine theta over cos theta d theta. That's what you have there. Then here you can use this property, the one we looked at when we were starting. You see, when you have this, you see this one will give you, when you differentiate this one, you get this one. When you can let your u equal to cos theta, and then you can find your du d theta being equal to minus sine theta, and then you can you're going to say your d theta is going to be minus du. So that will give you minus du over sine theta. Isn't it? Then this one, the integral of sine theta over cos theta d theta will turn into the integral of, this one is sine theta over cos theta is u here, times d theta is du over this one. It's minus du over sine theta. So this one is equal to the integral of, so you see the sine theta will go into the sine theta to get 1. And then you're going to have, you can pull out the negative outside, then you have 1 over u du. But this one, guys, so it's unfortunate we never looked at this, but when you differentiate dx of 1 over x, you get ln x. So when you integrate here, you get this one. When you integrate there, you get that one. So this one here is equal to minus the ln of u plus the constant. This is a logarithmic function, but you know what your u is? Your u is cos theta, which is equal to minus the ln of cos theta then plus c. You know, we've done logarithmic functions. You know the properties of logarithms. So you have a negative one here, which can go there. So this one is equal to ln of cos theta to the power negative 1, then plus c. But you know this one, when you have a negative power, this is equal to the ln of 1 over cos theta plus c. But this is familiar. You know this one is equal to the ln of sec theta plus c. And you're done. Okay, we proceed. So please, you should say if I'm too fast, if I'm too slow, we can still say.
No.
Okay, so let's look at, so we did definite integrals yesterday. So let's look at one definite, yes.
Pardon me, sir. I was just kindly asking that you should not forget to send the video. I'm about to have a class.
Oh, the video. Okay. All right.
Thank you, sir.
So this is what we have. So evaluate. So you have another question. So let us evaluate this definite integral from 1 to 3. And you have 5x by the root of 2x squared plus 7. Then dx. Wow, we have a product of 2. Yeah, so even here we can use this one here. This one. So don't be confused. This is what we're doing. So here we need first to integrate this. So here we let our u be equal to this one. What is inside? You have 2x squared plus 7, and then your du, your dx will give you 4x, so that your dx is equal to du over 4x. Now for this one of 5x, the root of 2x squared plus 7, dx will be the same as from 1 to 3, 5x. Then you have the root of this one, which is your u, then times du over 4x. Everything becomes simple. So you have your x and your x going. This one you're going to have, so you have 5 over 4. Du. This one is equal to 5 over 4, the integral of u to the power 1 over 2 du, which will be equal to from 1 to 3. Don't forget from 1 to 3. So this one is equal to, remember said this one is equal to, when you have this one, we had something like the f of b, a capital F of b minus the capital F of a. So that's what we are doing. This is a definite integral. So the capital So this is going to be 5 over 4